it means your B will remain stable, guaranteed. All right.
Sorry,
So-
Tim.
Yes, sir.
Sorry for interruption. Maybe there's two questions here again, maybe from Mr. Nam before it takes off. Can I go ahead?
Yes.
Okay, thanks. First question is from Mr. Rex. Is asking, do you support real-time monitoring and remote diagnostics for power quality? What protocols do you use, e.g., SNMP or else? That's the first question. Should I go with the second question or one by one?
Yeah, go ahead with the second question too.
Okay, thanks, sir. Second question is from Mr. Case. He's asking, what about reverse polarity protection? Can a VRP prevent damage if the input or output polarity is accidentally reversed? Thank you.
Okay. In terms of remote monitoring or diagnostics, we do not have it incorporated into the VRP yet, because we just believe in just maximum reliability as being our design philosophy. Just we don't expect VRP to go bad unless lightning strikes it and output goes to zero, and then you will know your equipment is down and you'll get some report that you're not getting power output from the VRP. As far as input voltage going up and down, that's part of my job. Our job is just keep output voltage constant, even if input is plus minus 30%, which is, you know, wider than anything else in the market. And we've had good. It does have three indicators, LED indicators: green, good, regular, working, okay. Yellow means it's on bypass mode. There's an overload situation or some fault condition. Then there's a red LED, which means VRP failed. So if you have somebody on site, you know, you can check those LEDs once a week or something like that. But another reason that we didn't want to give you all these diagnostic things extra is that there are some less expensive remote power quality monitoring devices that you can purchase from other companies. Hundreds of companies make these type of over voltage, under voltage alarms, and they send it to you via SNMP and other, you know, protocol. And a lot of sites I know already employ that kind of power quality monitoring and reporting system. And sometimes I say, you know, VRP is not an analog device. It's a more digital device, because we run on onesies and zeros. If the microprocessor stops issuing onesies and zeros, we just go dead. Output, it becomes zero. So, and that may happen on a normal, once every 10 years, VRP may fail. You might have to do some repair. But with that kind of a frequency, if you don't get a weekly or monthly report of trouble, so it just is useless in a way to monitor something that will never happen for 5 or 10 years. Why even bother monitoring the device when it's just like a piece of rock? You might, you know, when will the rock break and crack in half? Every 500 years or something, you know. People don't do that. So that's, and then there's less expensive, already well-established power quality analyzers and remote monitoring diagnostic equipment, et cetera, that's been in the marketplace. And I got involved so much. What was the second question?
The second question was saying, what about reverse polarity protection?
Okay.
Can a VRP prevent damage if the input or output polarity is accidentally reversed?
Okay, you must mean, you know, AC polarity It can only mean you have neutral and phase reversal, because we don't have plus, not like DC. You know, the AC mode is, you get phase 1, 2, 3, and then neutral and earth ground. I mean, if you mix reverse neutral, I mean, the earth ground, and hook it up to phase, you got big problems. You know, sparks will fly. So you want to make sure your uh, your earth ground is real earth ground, and you don't mix that wire. Neutral should be also very, very sacred on a three-phase system. Having the correct neutral, we depend on having the correct neutral input, because as you saw on the presentation, there are three different independent voltage regulators, VRPs, working simultaneously. Each one works between neutral to phase. So once you have that correctly, then neutral earth ground is in wires in the right place. The VRP will just continue to operate. Now, if some machines, I don't know, if you have phase reversal mix up on phase A, B, C, we can't correct that. You have to make sure that your phase relationship is correct on A, B, C, so that, because we cannot do anything about that phase relationship. So if it's reversed or changed, the incorrect sequence, this phase sequence is incorrect, we'll send exactly the same thing, but it won't damage our product or anything like that. Single phase machines really don't care whether hot phase and neutral is reversed, by the way, because you know that you can reverse your single phase plug, and you can have hot or phase going into neutral and neutral going into phase, vice versa, or you can have it correctly. No equipment would ever have a problem, because they always use isolated AC to DC power supply of some sort, so that it's allowed to have reversal, phase reversal on a single phase. I hope that answered your question.
Thank you, sir. I think if there's sorry, is asking, can your solution work seamless in setup using lithium batteries and solar energy with limited grid availability or unstable AC voltage supply?
Could you repeat that question? I didn't quite get that.
Is saying the question that we are answering, it's okay. I'm saying thank you. We got the response from you. So now is asking, can your solutions work seamless in setups using lithium batteries and solar energy with limited grid availability or unstable AC voltage supply?
If you are 100% running on solar power, solar, battery, and inverter, chances are you won't need VRP, because, again, the solar inverters are digital devices. They will typically produce 230 volts, or they'll produce 0. They don't give you swings of plus minus 10, plus minus 15% swing, because they don't have to. They got a microprocessor that's got a PWM technology just like ours to ensure that it's always producing constant 230 volts. So, but if you start mixing sources together, like I said, generator voltage could swing up and down depending on the load and quality of the generator. Also, the utility AC from outside got all kinds of problems with voltage surges and spikes. That's where the VRP will be absolutely necessary if you want to maximize your uptime and maximize your lifetime of your equipment. I hope that answered your question.
Okay, thanks, sir. We don't have any questions so far at this time. You may go ahead.
Tim?
Okay, from the audience. Yes, I'm here. Any questions? We just have a few more minutes before we head out for lunch. Any questions from Lagos? Any questions from Enugu? Can you get Enugu, please, quickly? Any questions? Oh, yes, sir. Now, stand by. Mr. George has a question, but let him introduce himself to the company he's representing.
Yeah, good afternoon, everyone. My name is Engineer George Towodu. I'm representing Mantrac, dealer of Caterpillar in Nigeria. My question goes, the first one is, do you have a solution for quality as related to harmonics? Okay. And the second one is, what are the parameters that are required from you for you to be able to provide a solution for me? So I have a site that is having a power quality issue, especially probably a data center, and what are the parameters that you will require so that I can help?
Thank you very much, George. Now, this question is about harmonics, and I know we're going to be dealing with harmonics by John Michel down the line and Jim. So, concerning the parameters that we require for us to be able to support you, definitely from site surveyor, we can capture for ourselves the exact situation of the network, and then we can provide a solution. It's going to tell us the voltage situation, it's going to tell us the dips, the sag, basic power quality requirements. For the harmonics, of course, we're going to be able to see. Now, this is very key, because the next session after the launch, we're going to be dealing with this whole area of power quality. I'm going to have Jim, who will be speaking about the SPDs, and then John Michel is somebody that you want to hear, okay? We're going to be talking about the instrumentation and everything power quality. I mean, we're going to shake the bottom pot right after the launch. Please stay put. All right, let me take quickly the introduction from Enugu, if you can get them. I know they're itching to say hello to Lagos. Can we get Enugu quickly before we head out? And please confirm that lunch will be ready in a few minutes. We have Enugu. Another question from somebody had an experience. They built a telecom site somewhere in Abuja. I don't know if Benson is online. Benson, are you online?
Yeah. Enugu is here.
Can you put a zoom on the screen, please? Let's see if Benson is online. Okay. Enugu is up?
Yes.
Okay, Enugu is up. Can we hear their voice? We're not hearing you, Enugu.
Yeah, I can hear you. We can hear you.
Enugu, I see it is muted.
We can hear you. All right.
Enugu is muted. I'm not hearing them.
No, nobody is asking question. All right, hold on.
Somebody watching from the YouTube, can you tell Enugu to unmute?
Greetings, wherever you are, across the globe. Thank you. My question is about the adaptability of this technology. Just to ask if, first of all, it will be accepted within the governance system of Enugu and Nigeria, and secondly, whether it will interfere with the already existing infrastructure that may cause some legal issues. Thank you.
All right. I know this is Enugu, right? The question from Enugu? Okay. I know we missed the introduction part to know which company he represents. Well, in the presentation, we did mention that we have this in already within Nigeria from long time ago, before we decided to go to Chinese. There is no regulatory interference with the electrical standard of Nigeria, okay? Actually, when we go to deal with the SPDs, which we have some samples here, do make sure that the color codes also align with the color code of the country. And that goes to say that these things are not off-the-shelf kind of products. They are produced per country, per demand. You don't buy them from Walmart. You don't buy them from any mall. If you go online, you can you have Savo model AVR from Italy, maybe something like Otia. Otia is a good company, but they produce double Savo, okay? 1600 kilowatts, that's 1.6 mega, okay? They have double Savo, good company, good thing for big buildings. Some of you may have them here. And you have a need for power quality. Let me give you a quick example before we go. After I have Mr. Vanaya chatting with me, I know that we have a situation with a customer in Tanzania. I would have loved to mention the name, but let me keep it quiet yet. They have a data center running on OTIA. And OTIA, they lost 4 UPSs. You know, you can imagine that. This is like a bank. And then for 2 days, bank is out. Customers are frustrated. Employees are frustrated. Some people are on the chopping box to be fired. And then somehow they reached out, and Alfred got in touch with me, and I said, okay, what do you have? Okay, they have OTIA. Leave it. Don't do anything to it. It's working, right? Yeah, but they see our problem. We will have the OTIA to leave. So, recommendation, we're going to put Saintama to the OTIA to protect the OTIA from the surges that are giving it, and it's going to be happening so fast. Hey, we're going to knock in VRP and see the network, 1, 2, 3, and we're going to go like laser surgeons. We don't have to give them 1.6 mega of VRP. You can't pay for that, too expensive. So we're going to go straight to where the problem is. Like laser surgeons, they go to the brain, they solve the problem, the hand starts moving, instead of cutting the whole hand. Okay? Simple recommendation. And that's it. You can't go beyond that. So when you talk about compatibility, we will work with what you have existing. However, we know what the problem is. We can improve what you have by clearing up the power quality, making it not to perform. The UPS are blowing up, your battery is no longer performing to the length of time it's supposed to do, like we have in Tanzania, NMB Bank. We'll be able to support you with Saintama. And just before I move away from that, this thing I just said now, I have somebody, I think somebody from Tanzania, Isaac from NMB Bank, I think I saw him online. Can you put a Zoom? Can you go back to Zoom? Let me see if Isaac is here. NMB Bank Tanzania. He's our major customer in Tanzania. Okay? The biggest bank in Tanzania. With almost 500 branches or so. More than that. Can we put a Zoom on the screen? Let's make sure. Let's take this quickly and then we go forward. Please confirm lunch is ready. You have the Zoom? Alfred, if you can hear me, can you book Isaac to open up and see if he can say something?
Yeah, let me check with him. But I see him, he's online.
Okay. Okay, as soon as he comes online, let me know. I was talking about a site.
No,
in
he's
Abuja,
connected, but
Benson
he's
is-
muted. Maybe you have to unmute him.
Unmute him, please. Unmute Isaac. What name does he have on the screen? Isaac.
Isaac.
Chimbi.
Isaac. Yes.
Yeah, Isaac.
And also tell PA is to be fine-tuned. The voice is not that much clear.
Okay.
Okay.
Is Isaac up?
Not yet. Still muted.
Unmute him, please. So in Abuja, they built a telecom site, 80 kilowatts, and it's supposed to be solar site. After building that, Benson is online, I think he's online. He reached out to me. There was no power. I mean, there was NEPA, but the voltage was too low to charge the site. As we speak, it's a current problem. You've invested 80 kilowatts, built a cell site, but you don't have power. The only option you have is to take a generator to that site to charge. But that's not the goal. What our solution would do is, no matter how bad the NEPA is, we can go as low as 50%. We have what we call VRP plus. NEPA brings the as low as 50%. That site will start working right away for the next 30 years. So that's the kind of problem we solve. All right, let's take it from Isaac. Is he there? Okay, we'll use him, we'll get his testimony when we do the sanctum after. All right, if there's no more questions.
Hi, team.
Hi,
Mr. Isaac is talking.
Yes, team. How are you?
Good afternoon.
Good afternoon. Sorry, I was a bit.
No, nzuri sana.
Yes.
Habari
Ndio,
za
habari. Salama kabisa za huko. Hongera kwa presentation.
Asante sana.
Yes, sorry, I was off the laptop. Maybe you can pardon a bit so that I can grasp what was ongoing.
All right, let's take you on for just for the next few seconds. You know, you've been using Saitama, I mean, you've engaged us for the past 10 years. We've been working with NMB for the past 10 years. Our classic situation was the mezzanine UPS was knocked out, batteries knocked out. And we came in, the generator was also having a big spurious problem. And we installed Saitama unit in the controller of the generator first, and did in the ATS, and then went up to the mezzanine panel, and the problem was completely solved. They never had to service that generator apart from oil change for the next 4 years. The gentleman from Mantrac can give you the contact, anybody can verify. So, Isaac, what is the experience of NMB Bank so far with what we provide? And why is it that you guys have chosen not to use any other product apart from beginning from Saitama? And I know now we're talking about the VRP, but the whole world, I mean, audience is listening to you to hear why do you invest so much in power quality?
Thank you so much, Tim. My name is Isaac Nchembi from Tanzania, and I'm currently working with NMB at the Power Specialist. As you had highlighted that till 2025, we have been in 10 years operating and using the Saitama surge protective device for our branches and data centers. Just to highlight the history, at first we were facing a challenge of lightning strikes, and our devices were being impacted, especially the network devices. This gave a rise that we needed a protection for it. Through these years, I won't give specific evidences, but just to highlight, we started with protecting against the lightning surges, and it was successful. Later, we had some impacts also from the power lines. We faced challenges that sometimes there's no lightning, there's no rain, but we find that the devices have been impacted by surges. So we had to widen our view that if the Saitama managed to solve the... Hello? Are you getting me?
We can hear you.
Yes, yeah. If Saitama managed to save the problem on lightning strikes and lightning surges, we got the confidence to try it also for these other power line surges, and it worked okay. To that extent, it took us to the next level that because at first we were installing to branches which
Yes.
were being impacted. For instance, if throughout the year, we get some 4, 5, 10 sites which have been impacted by these surges, we would list them out. Then in the next year, we would budget for them, then purchase and install. But it has come to our need that we are deploying now Saintema to all our sites, not being reactive, but either being proactive. So now in our standard design for the branches, we are including Saintema devices to be installed, and we are installing at 2 levels. We have one installed at the mains in Kama, and we have the second one cascaded on the main distribution board. What I can say, what we expected from the solution has been achieved, and we are happy, and we are confident to share this testimony that the device is working. And I'm not sure if this is just a privilege to our company, but we have been enjoying a 7-year warranty on these Saintema devices. But the worst thing is that the devices are not getting destroyed. So it's a 7 years warranty, but we're not getting from it. I think that's all which I can share on the Saintema. But as you know, whenever you are getting something good from somewhere, when you face another problem, you will invite them also to give their view. Currently, we are having a problem of low voltage to most of our sites, because we have some sites which are very remote, and most of the transformers are being overloaded. But also we have a problem of the voltage fluctuations. Previously, we have been using transformers to solve the problem. For instance, maybe we open a branch at a certain remote area. When we faced the low voltage issue, we normally contacted the utility company. They would come and make a survey, investigate, and most of the time the finding was there's an issue of low voltage and it's due to overloading of the transformer. And they would give us a quotation and suggest to us to install a dedicated transformer to the site. We did this. We were installing these transformers to resolve this low voltage issue, but unfortunately, because after installing the transformer, still the transformer is under maintenance or control or ownership of the utility company. So unexpectedly, you find they still install other customers to the same transformer, and the issue gets back to disturb and interrupt our operations. So when I had contact with his team, we discussed about this, and he proposed the VRP, voltage regulator. After investigating on it also through the through the network, and I was impressed with what I was informed. So I got into contact with my management and tried to explain to them what VRP can offer and what it can resolve from the cases we are facing as challenges. So I got to them with two points, which was the low voltage issue would be resolved, and the cost we are incurring on running the branches on generator would be reduced or will be omitted. So the bank will be saving a lot of money. Instead of using the generator during the periods of low voltage, then the VRP will be able to stabilize the voltage, and the bank will save a lot of money or a lot of costs instead of using the generator, which is costing us on fuel. But also, we are facing some sites which it was just fluctuation. You find that the generator starts, then after a few seconds, it stops. So you find it's just a minor fluctuation. Maybe the voltage goes down, the voltage drops for a few seconds or a few minutes, then the generator starts, but as the generator has started, then the mains power returns to the normal voltage, then the generator shuts down, so it's like a disturbance to the operations of the bank, of the branches. So with this VRP, which can stabilize the voltage within 20 milliseconds, which means we'll also be able to solve this problem. So currently, Scientime has already been engaged for the supply of the VRP, and we are in the final stages. I think in future, if I get a chance, I will then be another person to give a testimony on the VRP operation. Thank you.
Now it's lunchtime. Francis, don't go to bed. Now, good morning in the US. We'll be going out for lunch. You guys try to find some coffee for yourselves over there. Hiral, when we come back on the other side to talk about the support system and the warranty on this, definitely you'll be on board. Please do not leave after the lunch. Lunch in about 30 to 45 minutes, and we'll have everybody head out this way. It's exclusively for you. You're not mixing up with other people in the hotel. So we're going to go have some lunch. Now, the other aspect of this conference is going to be something you surely want to hear about. Okay? Not only will it create solutions for you, you probably might be in a position to take advantage of that to begin to build a future for yourself. Thank you so much. It's lunchtime, and when we come back, we'll be having Jim talk about the sign timer. Thank you.
Thank you, everybody. This is Nam. Bye-bye.
Thank you, Isaac, so much for your testimony.
So Tanzania will be back again in about 45 minutes. Don't go away. We are live on YouTube as well. We'll drop the link. So even if you have to step away from your computer, you will see us on YouTube as well. Thank you.
Today we're going to run a 6,000 volt, 3,000 amp surge test on this light bulb circuit and a very popular internationally known surge suppressor, Phoenix Contact, to see what type of positive benefit it'll have on protecting electrical equipment, but also consider the electronic equipment that is downstream. Suppressor is installed in parallel to the lighting circuit.
Recording stopped.
Introduce charging to 6,000 volts to be released into the peak of the sine wave. Wow. Imagine if that was your electronic equipment connected to this surge suppressor. Not too much protection at all. Let's change the light bulb and insert a sine tamer unit. Now we very carefully replaced the light bulb, considering all the broken glass, and inserted the sine tamer suppressor into the circuit, an LAST-120, 3Y2, just like the previous Phoenix Contact unit. Generator charging. Release the surge. No impact on the bulb whatsoever. Let's do this test one more time. And in fact, we could continue to do it for multiple times. But just for the sake of, you can see it happen here, let's charge it again. Release the surge. And again, just a flicker. Now you can see the benefit of having the sine tamer suppressor with its lower residual lead-through voltage rating to absolutely provide complete protection for electrical and electronic equipment.
Fox cameraman moved out of the way and into safe positions, and some shots of these lightning bolts were scary stuff. And that happened right near the 18th green again. Our lock cameras caught that bolt. And let me just tell you, it wasn't too far from our booth. That is a live look at the tree.
Okay, today we're going to run a 6,000 volt, 3,000 amp surge test on this light bulb circuit and a very popular internationally known surge suppressor, Phoenix Contact. See what type of positive benefit it'll have on
I want to see if you can just do it right here, like. Take 1 minute. Or if they captured anything. What's going on with your WhatsApp? Oh no. Hey, Kika, we're kicking off right now. Are you on your screen? Can you broadcast to everybody that second session is starting? Put a broadcast to people that second session is starting. I'm going to send a broadcast as well right now. All right. Angie, are you ready? Okay, do you have the NTA person there?
Yes, I've told them.
Can the NTA person see us on the screen? Can you come and see if you can see us? Can anybody see our screen? Media, can anybody see us? Angie, can you see us in Enugu? Okay, what is the NTA person? Okay. All right, welcome back, everybody. Okay. Welcome back to the second session. I hope you had a good lunch.
Recording in progress.
We still have our audience from different places. And can you unmute quickly? Just before we swing in, let me say hello to Kenya. I have Mr. Cosmos. Mr. Cosmos from Kenya, I see you there. This second session is going to be dealing with, we're getting deeper right now. We've dealt with voltage. This second session, we're going to be dealing with the surges, and the product is something you're going to feel right here, okay, because we have different samples for you here. And the tall man behind me, if you want to try me, I got a tall guy. Jim will be So the Saintoma product is the #1 surge protection device in the world. I mean, #1 not because I'm involved, it is proven, okay? So what you're going to hear today will prove what I just said. Okay? We have the testimony from Isaac from Tanzania talking about
the one that 10 years ago, upside down fast.
that. And the good thing is I have my president here. Jim is the MD for Africa for Energy Control Systems. And there's a wonderful man with a nice beard, Jeff Edwards. He just was able to avail a little bit of his time to say hello to us in this.
It's good to be
in Texas. Yeah. Hello, Mr. President.
Greetings, Timothy. Greetings, everybody.
Good evening. Good afternoon, Jeff. Good morning in Texas.
Morning in Texas. We get the first cup of coffee.
Oh, yeah, that's good. And Jim is right here. I'm boasting that I got a very tall gentleman behind me. In case anybody wants to try me, I will call my tall guy to deal with him.
Go get him, Jim.
So, Mr. President, we'll let you say hi to the audience. We have people connected from Kenya, Tanzania, of course, Singapore, US, India. And we have people sitting in the room in Lagos, and we have people sitting in the room in Enugu. I understand we have people connected online also from Onitsha in the east and in some other parts of the world. By the way, I think it may be a little bit late right now. I may have to check. Papua New Guinea is connected. Australia is on. Australia is on, and Papua New Guinea is also on. So we are not just one small people in one corner. I think we are reaching out to as much as the Lord gives us grace to different parts of the world at the same time. Thank you for the privilege, sir. Let me leave you with the floor to just say hi to them, and then Jim will take up the presentation.
I just, again, want to thank everybody for giving up their time. Hello, John Mitchell. Good to see you. It's going to be a very interesting presentation. Without a doubt, the words you'll hear will effectively change your life, improve your peace of mind, and give longevity to all of your electronics and microprocessors. So thanks so much, and have a great afternoon.
Thank you, sir. In Tanzania, I'm sure you are smiling seeing Jeff again, and Samsonite. I'm sure you guys are smiling seeing the face of Mr. President. Thank you. All right, we're going to leave the floor with Jim to make a presentation on Saintoma, and then right after him, he's not going to take so long, we're going to move deep into power quality. We're going to have John Michel from UK, from CPU Automation, the man that is shaking the world with power quality, to speak with us. Thank you very much. Jim, over to you.
Thank you, and it's lovely to be here in Nigeria. Thanks to the hotel staff who have done an excellent job, and for our technical staff in the corner there who are who are got everything under control. And I just thought I would open up with a couple of general comments about our partners here, not only in West Africa, but in the rest of Africa as well. And just in terms of what they can offer you as clients, not just here in Nigeria, but all over Africa itself. And I think it's worth mentioning that electrical quality problems are made even more tricky by the fact that you can't see them, right? If you've got a mechanical problem, like a wobble, for example, you can see a wobble, right? So you immediately know just intuitively by looking at it, right, that you've got some kind of a problem here, right? It's not so with electrical problems, right? You have to have some means of making that visible. And one of we think is one of the great advantages of dealing with us and our partners is that we can actually show you what those problems look like, right? We've got means of measuring those things and objectively showing that to your clients and say, this is the problem that you need to solve. I say that would be the first thing I would say, right? The second thing I would say is that we then have the solutions across a wide range of power quality problems that we can offer as solutions to you. And this is based on reports which we can do for you. So once we've actually measured what the problem is, we can give you a diagnosis of that. We can give you graphs, we can give you the data. You send that to us, and we've got guys within our organization who will be able to analyze that data for you. You'll have all the graphs, you'll have all the charts, you'll have all the data. But most importantly, you will have an executive summary of what the problem is and what the solution, the recommended solution needs to be. We've got a wide range of partners, including all the people in the room who you heard from this morning as well. We count them as part of the team because we've each got different bits of value to add to that power quality problem. We can supply these products, and I think the third thing to say is that we have an excellent reputation in terms of these products for reliability. So it's not just a brown box sale. We're not just selling you a product. We're selling you a product that will be absolutely right for your application. Because some of these things are expensive, right? They run into, tens of thousands of dollars. So it's not really viable for us to give you the wrong thing, ship it all the way here to Africa, install it, and then it doesn't work, right? So that's something that we can't really afford to happen. And it has to continue to work once it's in place. So I think that's kind of, amongst ourselves and amongst our partners here throughout Africa, I think that's a good USP that we can offer to you as clients. And with that in mind, let's go to the first of those product ranges. And yeah, if you could move on to the next slide, please. Thanks. And here's Jeff's headquarters, where you just saw him from. So he's based in Fort Worth, Texas. This is the head office of ECS, the manufacturers of Syntema. The product is manufactured in the United States. Thanks. Does this look familiar? So this is the kind of situation that you might encounter in your particular plant or whatever it is, right? And the immediate thing that strikes you about it is it's just complex. And that complexity seems to be increasing almost with every passing year because the technology is constantly evolving as well. Do we have power quality issues? Of course we have power quality issues. And what makes those power quality issues worse is the fact that the microprocessors which drive them are becoming more and more sensitive by the day, by the year. And what that means is, whereas back in the 80s, you had voltage levels inside the electronics in the single-digit volts, that dropped down to microvolts, first to millivolts and then down to microvolts. So any kind of interference in your power supply that's supplying power to these devices can have a very, very deleterious effect. Also the clock speeds. The clock speeds have moved from the megahertz up to the gigahertz. So what you find is the speed processes have gone up 1,000-fold and the voltages have dropped by 1,000,000-fold. So what never used to be a problem in the 80s has suddenly become a very big problem in the 2020s. So we have to find the budget for it. Is the money in the budget? Well, it's all about downtime, isn't it? And we all know, we're all very much familiar with the problem of downtime. And if you are in your plant and you just don't seem to be able to get to the problem, you've got a machine there. It might be a robot, it might be a PLC, it might be a drive. And for some reason, this thing just is not behaving, right? But what you do find is that when you go and cycle the power, when you switch it off and switch it back on again, then suddenly everything seems to come right. If you find yourself in a situation like that, it could very well be transients that are affecting it. Very, very difficult thing to see in the plant, but if we do an analysis on it, we can identify if that is indeed the problem. And if you don't want to go to that effort and expense of actually measuring it, you'll hear John when he comes on and talks about it now. Why not just try it? Put in a sine tamer and see how it affects. It's not a huge investment for big companies like yourselves. Try it and see. And you, I'm sure, because John, when he comes on, he's going to give you literally hundreds of references where we've had people go away as satisfied customers. So what we're going to do is we're going to a little bit of the theory as to how it works, but then the best recommendation that I can give you is actual success in the field. That trumps everything. Is it a surge protection device? Yes, it is, and no. And the difference, the clue is in the cost. An average surge protection device is a fairly inexpensive item. A sine tamer is a much more expensive because it's a much more complex item. So all that to say that the comparison between a sine tamer and a surge protection device is not really valid, because what it does is it protects in 10 different modes of protection. And we like to call it rather a frequency and attenuation device. That's a more accurate description of what a sine tamer is rather than a surge protection device. And you may have heard some of these comments, and yeah, you can go into the next slide, thanks. So, right idea, but wrong technology. Yeah, keep going forward, thank you. And again. And this is what you're generally going to find if you have a look at it, if you start doing an analysis of it. And what I would say is, typically when you're looking at any kind of a surge protection device, you're going to have a positive voltage and a negative voltage where the MOV actually triggers. So if it gets some kind of a over voltage spike, like a lightning strike, that is when the MOV activates. But what it's not doing is it's not catching all these little transient events which happen on the sine wave. It's only clipping positive and negative, not all the way along the sine wave here, right? And where that can be particularly damaging is at the zero crossing point. So if you get one of these transients at the zero crossing point, and that goes in through the rectifier and into your electronics, what it can do is it can confuse the logic, right? So all of a sudden, instead of reading a 0, it's reading a 1. Can you see how that works? And that can be the situation where the thing was working fine and now it's not working fine, that I mentioned earlier. It can just be that little logical switch that causes the machine not to work anymore. And that leads to downtime. Some downtime is better than others. In some plants, downtime can be just a case of switching the thing back on again. In other plants, it's not quite that simple. There might be a whole process to restart the thing again. So downtime can really turn into a nightmare in terms of the cost. Thank you. Thank you again. Yeah. And this is the paradigm shift that we're talking about. So it's not really, this is the difference between the third and the fourth generation of technology. If you have a look at the diagram there, the fourth tech, you know, it's like race cars. It's like a NASCAR at Indianapolis with an old delivery truck running in the race as well. And there's the clamping levels that I was talking about earlier, right? With the standard SPD, that's what you would get, right? Surge protection device. Thank you. And here's where sine tamer comes in. So what it's doing is, you've got your network here, and you've got your equipment there, and all those transients are basically just disappearing into the sine tamer based on 10 modes of protection. Thank you. And here's your ones and zeros that I was talking about, right? And you can see how, as the slide advances, you can see how that's going to be affected by the logic that we spoke about earlier. Thank you. Causing software confusion. Thank you. Now, if you have a look at this graph here, everything looks fine, right? But we have the type of equipment that we can supply you with or lend to you or hire, where you'll be able to have a look at that on a closer basis, right? And to see what's actually going on. And that's what's going to happen here as we zoom in. Thank you. So there's your ones and zeros. And now we're going to go on and see that the clock speeds have gone from, like I said earlier, from the megahertz range up to the gigahertz range. And the next slide will show how the voltage is. That's fine. So rather than doing the clipping at the positive and the negative, the way the sine tamer works is it tends to keep the transients within a certain percentage of the actual sine wave itself. So it doesn't allow the transient to get to a level higher than a certain limit above and below the sine wave. And so what that does is it also keeps down the energy that is involved in the transient as well, so that it doesn't get up to a destructive level where it can damage the equipment as well. Thank you. And again. And again. And you see we're zeroing in here on the actual transient, even though it's almost invisible. It's at the zero crossing point, and that's the problem, right? Thank you. And again. There it is. And again. And these are the 10 modes of protection, right? So the 10 modes of protection are between the 3 phases. So there's 3. You've got between the 3 phases and neutral, there's another 3. And you've got the 3 phases and ground, that's another 3. And then you've got between ground and neutral, so that makes up the 10th mode of protection. Thanks. Keeping it within that frequency, as I say, better described as a frequency attenuation device rather than a surge protection device. And as I said earlier, by doing so, the lack of difference of potential in the mode prevents significant surge current from flowing through to the load being protected. So much so that we're able to give a 25-year warranty on the sine tamer. Yeah, it's big, but just bear in mind that the transients are doing damage all the time. So if you put in the sine tamer, we can't really guarantee it for 25 years after you put it in if it's been running for, say, 5 or 10 years with deleterious effects, because the damage is happening almost like a cancer inside the machine. But if it's a new installation with a brand new sine tamer, 25 years. Thank you. The family, easy to describe. It's on the table here, but rather than bombarding you with part numbers, I'll advance to the next slide and show you again. So there's 6.9 kV AC models and DC panels up to 2000 volts. Thank you. Individual load protection models. Thank you. Next generation PCM protection, and again, the last one. Data and telecoms models, now which they've all got different part numbers and all got different places within the circuitry. So let's have a look at how we do this easily. We've got a model configurator app on the website, and it's as simple as this. The first drop-down menu, you've got a choice of 3 things. It's either a distribution panel, it's a variable speed drive, What's a PLC panel or a robotics panel? You pick which panel it is that you're trying to protect. The next drop-down menu is the current. You put in the current, and it will spit out for you, thank you, a circuit diagram showing you where to exactly put the sign tamer. And in this case, there's two required, right? Because there's an attenuation. So there's an attenuation that happens. So this one will get 95% of the surge. And if you need even extra protection, this one further down the cascade will get rid of the rest of it, another 95% as well. So there you have it, a circuit diagram showing you exactly where to put it. And next slide, please. The part numbers. And then next slide, the data sheets. So you've got everything you need. And if you can't figure it out for yourself, by all means come to us, we'll help you, make sure you get the right thing, rather than sitting and talking about all the different part numbers. As simple as that to define which product you need. And it's a who's who of people all over the globe who have installed it. And this is just a quick reference. I've chosen 3 African countries, companies. So these are 3 African success stories. We've got IHS, the tower guys. We've got, yep, thank you. And more rollouts planned to other sites, thank you. The Health University in Dar es Salaam, another success story. There's Jeff himself. And it's just, you know, you're going to hear from John himself about how successful they have been with this product in the actual field itself. And just go back one, sorry. Again. Okay. That's basically it, guys. I've got not much more to say because we're limited for time. And we've got far more authoritative people who will be able to speak on with far greater authority. Thank you very much for your time and for coming, guys.
Thank you, sir. Thank you, Jim. And we're going to swing in with John Michel, okay, right away. And thank you, Tanzania, for being patient. And Mr. Cosmos in Kenya. Can you put back the Zoom on the screen, please? Let me make sure I'm seeing them. Thank you, sir. Okay. All right, I have Benson. Benson, are you available? Okay, John is there. Great, I see him there. I see. Excellent. Okay, we're going to move into the next one now. I know you are all wonderful people. If it sounds a little bit above your head, don't worry. We'll have a video recording that you can go back to digest whatever John is going to download for us briefly, okay? And then he's going to talk a little more about the instrumentation at the end of his presentation, possibly the things that will help us to monitor these things. We just don't work blindly to solve power quality problems. You know, like they say in Nigeria, I'm not sure John has his experience, but I'm confident Jeff has had experience. Oga, you know, they work. Switch them off, switch them on. We don't do like that. We investigate. We want your money, but we just don't take your money just for money taking sake. We don't solve problems. We want to give peace of mind. You make an investment in Saintema or in any of these products, your child can come back to the same company and find it working. First installation in 2012 in Tanzania is still running. Installation in 2012 in Lekki Phase 1 was just recently replaced. 2012 was just recently replaced because there was no time to start to investigate. It's under warranty. You guys get a new one. So this is what we are bringing. Integrity under the warranty and the best technology you can think of. All right, I will head over to John to hit it on. Tanzania, please get ready. Enugu. Pay attention, this is going to benefit those factories. Now, some of you talked about power factor correction and all those stuff. John might touch up on those things, okay? But let's take it from here. Like I said, we have a recording that we will share with everybody that attended. Just make sure we have your email address. Thank you. Over to you, John, from CP Automation in the UK.
Thanks, Tim. Appreciate that. Thank you, everyone, for making the time. I'm just going to get my presentation shared. Can everyone see my presentation? Yeah, good, great. Okay, great information you've had before. Anything I mention on here, like I said, it's been recorded, but if anyone has further questions, please reach out to Tim and Jim, and then I'll happy to give feedback or extra information you may need. A copy of this presentation will also be available via PDF that Tim can pass out to you guys accordingly. Again, thank you for your time. We've been working with Jeff and the team for a decade now, and we've had some fantastic successes and some excellent successes, I have to say. Just to add one thing on to what Jim mentioned earlier, which I think was a really good point about the sign tamer doesn't fix cancer, but what it will do is if something has cancer, it will give it a much longer lasting life than it was planned to have. So it extends your asset whilst it's already damaged, but as Jim rightly said, if the item is already damaged, it's doomed to fail at some point, but the replacement unit you put in place once the sign tamer is already in will be doubly protected. And we've seen this firsthand time and time again. As Jim mentioned, we have hundreds of case stories just in Europe alone. Jeff has millions of case stories if you add them all up globally, no joke. So if you have a case where you think you have a problem, by all means, please ask Tim, and he will probably be able to find you a reference of some description within everyone that's sharing. And I really encourage you as partners, if you're having success in your region, please feed that into the team because it will help one of your colleagues or partners also sell the product. So, and convince the customer this is real. It isn't fake. It's not an empty box, even though it's very light. There is some clever stuff going on inside. Right, let's move forward. Again, thank you for your time, okay? So I've got some topics here. We've got a certain amount of time to get through. So this is a topic that would probably take about a week if we wanted to go through everything, and we have maybe half an hour to 45 minutes. So let's see how we go. Often in this field, power quality, we're considered experts or wizards. I'm trying to grow my beard a bit longer to look more like a wizard, but I'm not quite there yet. Jeff is the white wizard. I am the grey beard at the moment, getting there. In reality, though, we are just engineers. In reality, though, we are just engineers having fun, and that is the truth of it, right? Every day is a school day when it comes to power quality. If someone tells you they're an expert, I would question that already, because having been doing power quality for well over a decade, even yesterday, if any of you see my LinkedIn posts, I was completely stumped by a problem the customer had. Now, we helped it with Sign Tamer, but they had two problems. The Sign Tamer solved one, and now we have to investigate the other. So every day is a school day. So please, and no question is too stupid in power quality. So why does it matter? I think most of you already know this. So this is in the presentation for you to use later, maybe with your customers. But it's to show the customer that they should have something that is considered clean. And many things in the site are going to cause that to be unclean. And that will affect the equipment. Obviously, what we'd like to know is that there's a symbiotic relationship between the load, the power supply, the grid, or other sources, and the loads. And they should be working together in a clean environment. I'm a prime example that I am at my healthiest when I'm giving myself good nutrition and food. The reality is, if I live my life off of, not going to name any names, but some fast food chains, my body gets worse and I start to feel ill and I get sick. It's the same with your electronic equipment. If you're going to give it a poor power quality signal, it's going to fail ultimately, or get worse and then get sick and then eventually fail. And that can happen over a period of time. And a lot of people forget about this, but products today are designed to live 7 to 10 years in a good, healthy environment. The reality is they probably live in somewhere between 3 and 6. And that 3 and, or even less, but that 3 and 6 is not because the product's made cheaper. In fact, the components today are a lot more robust. The reality is the network is destroying the components sooner. But it becomes acceptable behavior that after it's installed 3-4 years from now, someone goes, ah, yeah, we'll just replace it. And no one logs root cause analysis anymore. So again, the importance of having a sign tamer is really important to give the asset its potential life that it was invested in. There's loads of studies out there. Here's just one of them. Lots and lots of money. Whatever your currency is, convert it. It's a lot of money in the billions of dollars globally being spent on issues related to power quality. That's wasted money. And there are a lot of different studies out there by all different people, and they all say pretty much the same thing. So we shouldn't be spending this much money on this. There are better things to invest our time and money in, including charities, for goodness sake. So, right. These are some of the things you might see. You will see cable failures, PCB boards failing, etc., etc. There's a whole list there. You can read them as well as I can. But basically, capacitor banks will fail, especially if they're not detuned. Due to harmonics and other things, transient spike in the cable. Anywhere you hear that your customer has a fire is a great opportunity to get involved with your client and help them, because a fire is a prime example typically of harmonics and transient problems related to the site. These are some of the symbols you can see here across the page that are typical, the sort of 6 or 7 typical power quality problems, and listed down the side. Voltage sags and swells, harmonics, super harmonics, which is, I would say, become more of a hot topic in the last 2 or 3 years. I've been talking about it for 5 years, and people thought I was nuts until I could prove to them and show them the epic thing a sign tamer does to stop this problem, in addition to its normal job, which is the transients and surges. Flicker, wave shape changes, and all the other things that can be going on in your factory. And one of the key things is being able to measure that, because if you can measure it, you can fix what you know. That gets measured gets improved. That's a quote from someone famous, not me, but you can claim it was me if you wish. So let's get into metering, right? Because metering is going to be the basic fundamental part of it, and choosing the right meters enables you to have your eyes wide open. A lot of the time I see people buying meters, and they're really cheap energy meters, give you no information, completely useless, but someone spent some money and it's doing nothing. So what do we need? Well, you can have fixed meters, right? So your customers may already have these. I've particularly chosen Unitza here because that's a brand we're familiar with, but you may know Schneider, Socomec. There's hundreds of different manufacturers. Again, spending that little bit more money to get a power quality meter instead of an energy meter could be really beneficial for you to be able to help your customer understand their problems, especially one that can record transients. There are higher level devices like the P-Cube, which we actively promote. This tiny little device, which you can see, I don't know if you can see my mouse pointer down here. This is in a control panel. It's smaller than the size of a router, is able to capture the transients that a sign tamer will fix. So this device is able to put into a control panel, measure everything power quality wise, all the way up into super harmonics as well. But in addition to that, it will allow you to prove to your client, look, you were getting these transients before, now you've plugged the sign tamer in, those transients have gone away. So it's a before and after, black and white. The customer can even have emails giving a report of the transient and the event and when it happened. And believe me, when they put a sign tamer in, they're not getting those emails anymore. There are other devices on the market. You'll be familiar maybe with the name Fluke, global enterprise of selling yellow type devices. These are Chauvin Arnaud, a French company in Europe, equivalent to Fluke. And their meters are great. They can measure transients as well as a portable device. There's the Qualistar, which is the one on the far right there, can also measure up to quite high order harmonics. But then we have another product made in Germany from a company called Eberle that we promote. And these devices can measure both the transients and super harmonics. And they are excellent pieces of kit if you want to prove. We've never sold so many sign tamers since we started using these devices to prove black and white to the customer. We turn the sign tamer on, show the problem gone away, we turn the sign tamer off, and show again. I'll show you that in case studies later anyway. They're just in there for reference in case you're looking to learn more about that. So what kind of problems do we have? Basically, most of the time, people have power quality problems, and it's a reactive issue. And what do I mean by that? They've had a failure, they've had a problem, and now they're reacting to it. If you put the meters in, you can register when these things are happening and then put mitigation in and show that those problems have gone away. That in itself is enough that customers don't need to worry, specifically when it comes to root cause analysis. Maybe they can get the data to go, oh, okay, there's nothing we can do about that. We had a grid switching transient. We're going to put a sign tamer in, that's going to go away, and we don't have to spend half a day or a week investigating why all my equipment blew up. It doesn't even have to be the equipment blew up. It could be that it's misfunctioning and they're not even aware. Maybe the operational efficiency of the production line from, say, Coca-Cola or someone else, they could have a lower OEE that week just because they had all these transients messing up with I/O. So, yeah, getting into the information, you can do basic reports and standard reports and complicated reports. I won't go into that today. It's a whole other topic. And you can get to catastrophic failure issues so you know when events have occurred. This can be quite powerful information for your client. And this is remote access as well. So you could be proactive with your customers and say, hey, you're having a load of transient problems. I can see it because you've got access to the meter maybe. Or you're getting the emails that you set up from the meter. And then you can be proactive and say, hey, you're getting all these problems. Can we come in and talk to you about Sign Tamer and how it's going to help you? Okay, that's a bit on metering. Rant over. So the next thing is really to do with harmonics, super harmonics, and power factor correction. Many of you are familiar with maybe this beer. Maybe next time I can come and visit and we can take a beer and try and get some of that extra froth away so we have more beer in our glass. But you understand the principles of this, so I don't think I need to teach you on this. But there are things to be considered, and that is that there are different types to improve power factor. If their customer has old power factor correction installed, which typically is, they would have upgraded to VSDs at some point, variable speed drives. And variable speed drives and old power factor correction do not like each other. They are not friends. And the reason for that is because just capacitor banks are a sink for harmonics, and the variable speed drives create harmonics. So what can happen is you can get a resonance. And when that resonance occurs, things start failing. The capacitors will burn out, the drives will fail. Again, having a sign tamer on the panel to protect the drives is a really good idea, especially if you don't know what else is installed in plant. The other way is to have things called detuned capacitor banks where they've got chokes in front, and that is a real help. So it doesn't cause it eliminates most of the resonances issues. Not all. And then there are some other modern technologies on the market today. So we offer a product called an ESVG, and this is an electronic way of handling power factor correction. It's using basically like drive technology to improve it, and it's dynamic, so it doesn't wait for the steps to change and step up. It's instantly modifying the power factor on the fly. And then the other way is to do it in an active harmonic filter, and that's a whole topic as well, but we'll get into that. Harmonics are caused by drawing nonlinear loads. So back in the day, we didn't have harmonic problems because we just had direct online motors or star deltas. We moved to soft starts and then we moved to VSDs, and these are causing harmonic issues. There are technologies that are less harmonic creating, but there's ways to mitigate that. If you get too many harmonics on your system, eventually it would become a square wave, and that's not good for any piece of equipment running on AC. And what can happen is if you get too much harmonics caused by all the different loads, they summate at the transformer and cause it to overheat, as you can see in this picture here on the bottom right. There is something else I'll get into in a second, which is causing transformers to derate, called FHL, similar to K factor. It's called harmonic loss factor, FHL, and we'll come to that in a second. But yeah, there's a lot of problems that can occur when your transformer's not happy, so let's keep it happy. So this is FHL, and what FHL basically means is that it's a way of working out, is your transformer happy? Are the loads that are being drawn affecting the transformer's capability to keep a stable voltage, a healthy voltage, without distortion? Not many people talk about this actually, and what we've been able to do with many customers now, here's a prime example. This is a real life case study. It was a 2 MVA transformer at dairy, and they only had 180 kVA spare capacity on the transformer when we visited, because they had a lot of harmonics on the transformer. And the current harmonics are causing distortion in the transformer and derating the transformer. So the voltage distortion goes up and the transformer's rating of power goes down. We installed an active harmonic filter onto this system, and we released 600 up. We pushed them back up to 600 kVA spare capacity, which meant they could add the additional loads they were planning for instead of buying a bigger connection from the grid and a bigger transformer. So this is something else to consider. a lot of the time people think we'll just go bigger and put something else in, but actually you can make your existing system more efficient if you understand why it's inefficient. And we can help with that. You can do surveys, so you can buy this equipment that we talked about earlier, the portal equipment, you put that in, you measure it, you can send us the file, we can help run your report and that kind of thing. Another thing people aren't aware of is voltage distortion, which is caused by the current distortion into the transformer, can make direct online motors inefficient. And if you see there at the bottom, if you had a voltage distortion of 8%, which is kind of the limit that the standards dictate these days, a motor DOL can run only to a maximum of 85% of its load. So you've derated your on-site motor's power by 15% by not fixing the current harmonics going to the transformer. This is just a list for a bedtime reading of some standards. Forgive me, I'm not 100% familiar with the standards adopted across the African nation. I know NRS 048, I think it is in South Africa, but I don't know what's used across up north. So have a look at your local standards and see, but they probably conform to these, or you might even be using the American standard, which is kind of globalized to IEEE 519. But either way, 5% voltage distortion should be the ideal upper limit to make sure everything on site is good. So here we're just going to talk about the spectrum now, just so you understand what we're talking about when we talk about noise, right? So forgive me if people don't know, but on the left-hand side, we have harmonics. That's from the 50th hertz to 2 kilohertz. That's how it's defined in the standards pretty much globally. Then we have a bit of an overlap. We have supraharmonics, and that's starting at 2 kilohertz and going to 9, and then from 9 to 150. And then we have EMC from a drive point of view, let's say RFI, which is conducted, and then you have radiated as well. But we're specifically talking about conducted here. And that's what an EMC filter is doing, for those of you familiar with drives, is getting rid of the noise above 150 kilohertz. So supraharmonics sits in the middle, harmonics is down the end, and EMC is higher. And as you go down the spectrum, you need a lot more power and energy to get rid of that problem. As you go up the spectrum, a lot less energy to get rid of the problem. Here I'm giving a prime example that we use with our meter to show you the difference, for those familiar with variable speed drives that create harmonics, of a B6 bridge, which is a standard drive that you would buy, be it Siemens, Rockwell, ABB, doesn't really matter who they are. And on the right hand side is what we call a low harmonic drive, or AFE. On the left hand side you can see that we have these humps on the waveform. This is the distortion that's going to the transformer. So we want to get rid of that. On the right hand side we have a different problem. The active front-end drive is giving a nice sine wave, but it has overlapping high-frequency switching of supraharmonics over the waveform, and that can be detrimental too to the transformers. It can cause gassing in the oil analysis, as an example. Not to mention many other disturbances because of the frequency that it's operating at. So here you'll see a voltage of a 6-pulse drive. If you don't have a meter that's fast enough, this is what I was talking about, buying the right kind of power quality meter to measure and analyze the sampling frequency high enough, you would mistakenly see that AFE drive, the active front end drive, it would look like this. And to the naked eye, that looks like a perfectly good signal to me. The problem is it actually looks like this. So when you have a frequency sampling rate in the processor high enough to measure what's going on from the drive, you can actually see that all of those switching transients are going through the signal. And I have cases to show you this shortly. In addition to that, we can create a thermal map. So I can see on a plant, if we do a measure for 7 days, I can see which equipment is likely to be the problem with the frequencies that are being emitted. So, for example, electric vehicle charges, they will be at a certain frequency band. Solar arrays will be at another frequency band. UPSs, another one. Variable speed drives, and so on. So I can see at what time of day, maybe it's during the daytime, and I see a frequency, you have solar on your site. And I can see that that frequency is getting above the limit. So it's right, a thermal map is a really good tool to be able to investigate, without knowing the entire site, what kind of equipment might be causing the problems they're seeing. From that, I can break down specifically the frequencies. I won't bore you with this today, it's in the presentation. So now we get on to mitigation. And forgive me, this is a lot of information really quickly, and I'm not there, so I'm conscious that some of this might be new, and for some of you it isn't, so forgive me. This is just explaining about the different drive technologies. So you have variable speed drives with chokes. You can have EC fans for data centers and chillers. And then you've got variable speed drives with a passive filter or an active front-end drive with also a passive filter, an LCL filter. And these are the different technologies that would give you a different THDI, which is the current distortion going into the transformer. And you can see on the right-hand side, the green ones are obviously the better ones because they're going to be less than 5%. If you keep THDI below 5%, the THDV from the transformer will also be below 5%. In addition to that, you have extra losses because the THDI is a distortion which creates losses. So if you don't get rid of the distortion, you're wasting current and energy. And a prime example here, this is just for, again, reading later on. One customer chose between two different technologies, one example of a 200 kilowatt VSD. And the bottom figure here, you can see here the efficiency difference with the two solutions. That saved them £7,000 a year just in inefficiencies. That's a technology choice, nothing to do with operational. Yeah, you can read that yourselves later on. So passive filters look like this. They're a metal box with some chokes and some capacitors inside. These sit in series with the VSD and they will clean up the signal for you. There's a whole range of those available. Active filters, for those that aren't familiar, are like sound cancelling headphones. So what they do is they listen, they have a current sensor on the mains, they listen to the noise and then they inject an antiphase. It's a little bit different to antiphase, but very similar. A new vector that basically cancels out the noise that's been created. So in effect, then you get a clean signal back to the transformer. So it's mitigating on the fly at very high processing speed. And products like this are a prime example. So we partner with two manufacturers, one being Comsys and one being Revcon. So this is the Comsys filter, very comprehensive, robust product with amazing software and can also stop issues with resonance and other things like that because they have impedance control. So EV chargers, for example, can be quite problematic to mitigate the harmonics from, and we can do that easily with this product. And they go up to 690 volts. So these are LV connection products. And then we have Revcon, which is using silicon carbide. It's a lot smaller than other IGBT technologies due to using silicon carbide over IGBT. And the losses are about a third less as well. So it's about a quarter of the size and about a third of the losses overall. Then into super harmonics, as I mentioned in the section there, it's broken into two areas, 2 to 9 kilohertz and 9 to 150. For the 2 to 9, we have this product. And then for 2 to 9 in light industrial applications like shopping malls and stuff, we have this product. And then in addition to that, we fit the sine tamer that you can see there in the panel, and that will get rid of the higher frequencies. So we can do a really wideband filter solution for your customers. EMC we spoke about, I don't need to go into that, but we do an entire range of those if you ever need them. So Jim's already done a great explanation of transients. So this is just a couple of slides in there about transients. You already know what they are. They're spikes on the mains. Those are really fast spikes though, right? These aren't sustained over voltages. Most people only think of transients coming from lightning, but the reality is 80% of transients are created within your own factory or your customer's factory by their own equipment. That can be switching over between generator and mains. It can be fast acting switching direct online. It could be big chillers coming in and on and off. There are so many other things that can cause transients within the network. And as Jim alluded to, SPDs kind of look like this, right? And a lot of people will tell you, yeah, we have SPDs, but we still have problems. Yeah, there's a good reason for that. They're designed for a different thing, and that's not the problem that you have. So the core thing that I wanted to add on to Jim's presentation today is that the SPDs are kind of working in this area, and that's designed around where they were designed for, and that's what the standards for certain things were done by, because the people who wrote the standards were the people who made the product. But the reality is the transients that we're talking about that sine tamer's fixing are outside that window, which is why they never work. The sine tamer is working like 50 times faster to respond to something that's microseconds, less than microseconds, sub-microseconds almost, in terms of speed and it's capturing that and preventing that from being a problem before it becomes a high impulse issue. Jim's alluded to where they can go and what they do, so we don't need to go through that. And we've shown you that it basically takes that and almost eliminates it. It doesn't get rid of it 100% because there will always, you can never get rid of something 100%, but it gets it down to such a small amount that you wouldn't even know it's there unless you knew to look for it, which is what you want. You can fit one sign tamer. You see the bottom right hand corner there. This is a Crohn's machine. So you've got Allen Bradley Contrologics PLCs on the right hand side there. They're protected by a single phase sign tamer for the power supply. Then in each of those panels there, you've got Danfoss drives. And on each of those Danfoss drives per panel, you've got a sign tamer protecting that bank. That gives you an idea of what you can do in terms of protection and scalability, you know. And we've got loads of flyers. So if you've got an industry that you would like to talk to your customer about sign tamer, we've created a load of flyers for all different industries. These are just some examples to show you, but we've got steel, cranes, dairy, data centers, the list goes on. So again, please reach out to Tim and we can provide you with those details so you can use them freely with your customers. So why don't we show you a few cases that we've solved problems for. This is a compressor for a water treatment plant. Two ABB drives back to back, controlling a 630 kilowatt compressor. Kilowatt compressor. The drives were low harmonic, and what they were doing were creating a common mode noise that was affecting the Terasaki ACB. The ACB thought it had a ground fault of 816 amps. It wasn't real. The electrical noise was tricking the sensor to thinking it had something that wasn't there. What we did was, if you look on the left-hand side here, this was the switching noise of the drives that was affecting the sensors. We installed 3 sign tamers. We had to fit 3 because of how far away we had to try and mitigate the problem, because the people who owned the compressor, the OEM, said the warranty would be invalid if we installed a sign tamer in the cabinet. Even though 1 sign tamer solved the whole problem, but because we couldn't put it at the source of the problem and we were 100 meters away from the problem, we had to fit 3 in order to mitigate that. I have a video on LinkedIn for that. If anyone would like to see that, it's showing live me turning the sign tamers on one by one and then showing you the mitigation going down. Again, that's on my LinkedIn page, and again, we can share that with you. In addition to that, we installed some harmonic filters to mitigate some of the harmonics that were on site. This site, again, actually a water treatment plant, they have a pole transformer, which you see up here, and this site was using ABB FIRS surge arresters, which you may be familiar with. I'm not sure if you are, but FIRS have been around for a very long time, and then ABB bought them. They were failing roughly once every 3 months in this site, and no one had a clue why. They didn't want to pay for a survey, so we sent them out a sign tamer and said, look, I'm pretty sure it's a problem with how robust the boards are that are inside the ABB device. You're not going to have this problem with sign tamer. They fitted 1 sign tamer on one site. There was 5 sites in total, and they didn't have a problem for 6 months, not a single failure. So they then went and added them to the rest of the sites. They've been in over 5 years now, and their site has been protected from day one, never had a failure. Now those ABB units were, forgive me, I forget, but it was something in the order of around 500 or 600 UK pounds to replace. And the sign tamer was a little bit more, but once. And they had replaced about 5, I think it was, in total over the course of a year and a half. So, and would have forever been replacing them. So, you know, when someone talks to you about price, just think also, how about longevity? You're getting this for life. It's 25 years to life, and it's not an imprisonment. In addition, we solved some harmonic issues for the client. This is a flood defense application for the City of York, for anyone who knows the UK. And this was a £20 million government project to stop the flooding of the city when 2 rivers overrun. They were having all kinds of problems, which I won't bore you with today because it's a whole topic on all the problems they had. But the main problems we were there to fix were transformers having gas in the bubbles and gases in the oil results, which meant the transformer's warranty was being invalidated. And in addition to that, the ABB drives, which are active front-end drives, were causing problems with the generators. We came in, we measured with the device that I showed you earlier, we installed a HHF, which you can see here, which is the 2 to 9. And then we installed the sine tamer, which is the 9 to 150. So we had a wideband filter to cover all the problems I was able to measure. And as a result of that, on the left-hand side, this is what the AC mains look like under a high-frequency scope, i.e. the analyzer. Afterwards, when we installed the sine tamer and the HHF, we got the result like this. It's black. I say it's black and white. It's blue, red, and green. It's as clear as day. And here was a timeline. So what we did was we ran the drives up. This is power for the drives. You can see that the harmonic or the super harmonic noise was getting louder as the power went up. It continued. We switched the HHF on and then off again just to see how did the HHF do. Then we turned it back on. So it got us about halfway. Pretty good result because it was only dealing with one set of the problem. Then we turned on the sine tamer, and the sine tamer then cleared everything down to 0. So the combination of those two was an epic result for the client. And as you can see here, it's tabulated, but basically we got rid of 98% of the noise at 40 kilohertz, but also well over 60 to 90% of all the other frequencies as well. This is another site where they have a phase failure relay. I don't know if you're familiar with this product called Foxtam, but you can see here as well, here is a Dean red surge arrestor. This unit here caught fire due to superharmonics. It was capturing inside a little resistor inside the device. We installed a sine tamer and a HHF, and we cleared up all the signals. The customer was over the moon. But here's to show you, if you have an analyzer, hopefully you can see, it's hard. If your analyzer is not of high spec enough, it's hard to actually know that you've got a problem. I had to zoom right in on my Tektronix scope. I had all 3 on site to show to the customer, just to see the fuzziness. But with my power quality analyzer, I can see the overlying frequency, and with a click of a button, I know exactly which frequencies are causing the problem. We've just had this case here. We've just actually had a second case of this in Denmark today. One of our partners in Denmark just called me to say they've got a problem with a product called a Rotork valve. And it's a valve that it's an automated valve that rotates for borehole pumps. And what was happening was whenever the ABB drives were running, the valve and the well depth sensors were going crazy. Like they just couldn't read and they couldn't operate. We installed one sine tamer and all the problems went away. All of them. This problem had been investigated for 9 months. They'd replaced valves, sensors, computers. They couldn't get to the bottom of the problem. Literally in 5 minutes, I wired in a sine tamer and everything was working. Even the fire alarm stopped going off, which was going off randomly while we were there. Again, another pumping station one here, but you can just see, this is for your reference so you can see how clear we make the problem when we put sine tamers in. This one is an application where a customer had a weird problem. I was on site commissioning down the road and they had another site down the road and they said, we've got a sensor that's giving us really strange signals and we don't know why, but it means that we can't follow the flow rate of the river and then we can't pump and do other things. I said, oh, okay, let's go and have a look. I said, I can't say I promised to solve it, but let's have a look. Anyway, we installed a sine tamer and you can see here the sine tamer, this one has a counter on it. We had over 1,000 counts in a week recording. Sometimes I've actually been to site and we've had hundreds of thousands of counts, but this is different. This is for a signal issue. So we had 1,000 counts of problems. We installed the sine tamer and then everything started working. Now, if you look here, this is the data from the customer. This is not my data recorded. This is their analog signal into their PLC system. And you can see these spikes on the signals here. This is the point we installed the sine tamer on this date at roughly that time, just after 2 o'clock. Immediately, we started getting a normal response from the signal from the sensor. So this sine tamer was not put on the sensor signal. This was put on the main supply of the incomer to that panel, and it cleared up everything inside the panel. And then it worked seamlessly. That's been in there well over 3 years, and they've not had a problem since. This is a case study where we had great success with a partner of Rockwell Automation. So this is a Rockwell Automation drive here, a 753 VSD. This is our regen unit in a steel mill. This is Tata Steel. These have been working really fine for a little while, but the MOVs inside this drive started playing up and blowing. So when customers tell you that they already have products that have MOVs in them, so they don't need sign tamer, they're wrong. They really are wrong. The drives are built for a price, and they're not built for understanding what they might be connected to. There was 50 of these in total, and I think it got to the point that 7 had failed before the customer finally said, okay, what can we do about it, and called us in. Because we supplied the regen units, and the regen units weren't failing, they said, what's different? I said, well, we've got better protection inside our regen units than the drives. And they said, how? Well, I said, really, in effect, it's got a sign tamer inside. And they said, okay, from a protection point of view. I said, but you've also got some other problems, but we'll put one sign tamer on each panel. The drives were in banks of 10. And from that day, they've not had a single failure of a drive at all. And that's been in over 7 years. So again, just to give you an idea of how powerful the sign tamer is. This is another Tata Steel site, completely different, that we did last year. They have ABB drives and Nidec, which were Control Techniques, for those who know that name, drives, AC and DC drives. And they were having, last year, they were having a drive fail per month, at least, if not 2, per month. And their repair cost was getting expensive. So the company that was doing the repairs contacted me and said, hey, look, we're looking bad because we're getting a lot of repair business, which is great for our business, but the customer thinks it's something we've done to the site and we want to fix this problem. We know you deal with power quality issues. Can you come and investigate? We investigated, we measured, we saw the spikes, immediately suggested sign tamers. We installed 7 across site, 1 per panel for a bank of drives. They haven't had a problem since. It's been over a year. They haven't had a single failure. We have that as a case study that's in all the press. The customer was willing to write his opinion on what happened and how nice it was that he doesn't have to worry and sleep at night with these problems anymore. So again, I can't stress enough that to have the confidence to convince your customer putting the sign tamer in is going to make sure that their product lasts. Okay, that was a lot of information really fast. I've got a lot more information behind that as well. So should anyone be of interest to know more about power quality mitigation solutions or power quality problems, please liaise with Jim and Tim and see what you want to know. And if I have the information, I'll freely share it with you, because the more we talk about this and the more we share this information, the better it is for everyone. Okay? Over to you, Tim.
All right. Thank you so much, John. That was exactly as expected. I know that 12 hours is not enough for John to share experiences only. So, have you been loaded with some good information so far? All right, somebody may say like, oh man, I'm not too technical, but the information we're giving to you is to let you know, to make you an ambassador to the whole industry. And look, there's a solution. There are some people that have cracked that little window that will really help them become more profitable and more sustainable, and above all, have peace of mind. Okay, I mean, it hurts. You have your daughter's graduation and you are the plant manager, maintenance manager, electrical manager. On the day of your daughter's wedding, there's a failure in the plant and they call you, oh, we are down. And then you have to leave your daughter's wedding to go for plant down. That's crazy. We got a solution to keep you at the wedding now. All right? So I want to thank you, all of you. If you have any question right now for John for the next 1 minute from Enugu, any question? I do know that in Enugu we have a number of people that are running factories, heavy-duty factories in Enugu. And somebody from the government asked a question, how this will benefit. For your information, so much. You can't be talking about municipal wastewater management without power quality. Okay, we have, I'm not sure in Tanzania they are connected. We have a case right now that we are privileged to deal with. They bought something from Dubai and they bought from China, maybe Chint or something like that. In 1 weekend, those 2 solutions blew up. They thought the one from Dubai would do better. They put that one and that one blew up. So they had to come back to us. Okay? We're like, okay, no problem. We will solve your problem. So for the government, the person in Enugu that asked how this will benefit them, your wastewater management, your drinking water pumps, you need these solutions to really, really be stable. You don't want the water to go off on the whole municipality because equipment has failed. All right? So we can definitely help you. Now, we didn't go down the lane, some other kind of things that we may require. The industry already heard about the drives. You heard about ABB that you respect so much in this country. We respect ABB, we respect Rockwell, all right? But you can see how our solutions help them do better. Somebody will say, I'm from Siemens. We got Siemens right here, we got Schneider right here. Don't be afraid. When you are trying to do a project and Schneider is coming in, also try to ask some questions, Don't be afraid to incorporate us to make them better. And Schneider, don't be afraid to let them know that you don't do everything. John did not say we handle 100%. Nobody can solve it 100%. Okay? This is man-made. Okay? Unless God made, then we can say 100%. But if it's man-made, you got to allow it slack. Okay? Now, for the telecoms people, you had it from the beginning. For people like the Jubalis, the generator companies, solution is on the table right now. For the Lamberts of this world, building refineries, and the other companies building the high-rise buildings, the big elevator companies, the cranes, the solution is right in this box, power quality. And that's why we had to come down to spread the news, and we called you in, and we respect so much that you spent your time today with us. Our time is a little bit past spent. If anybody has a question in Enugu, please indicate in the chat. Any question? Any question from Enugu? No. If you have a question, we'll see a few minutes before we let John be on the sideline, and then we shut down. Last thing we're going to talk in just 2 minutes is the support system that we have. Now, Coca-Cola told me some years ago, we watched you for 3 years before we could do business with you. American Towers in Tanzania.
Hello. Hello, can you hear
Yes.
me?
Yes.
So the organizers, I thank you for what you have done so far. And I want to thank Jim Rose and John Michel for the presentation so far. I equally thank the organizer here in Enugu, Engineer Maka, for making it possible for us to be here today. I just want to tell
Can the camera in Enugu show your face?
Yes, the camera is here. My face is on the there.
Enugu, is it possible to see who is speaking?
It's very clear. Yeah. Can you see me now? Can I continue?
Continue.
So
Media, try to catch his face so we can see who is speaking.
I think it's very clear here. So
Good, we can see you.
So you can see my face right now. So I said I thank the organizer here in Enugu, Engineer Maka, for all his high efforts in coming to the ministry to talk to us about this very program. I equally saw people are partnering with the Amazons and the Boeing, especially the Boeing that most of us have been using worldwide. I just want to let you know that what you're saying is highly technical. When you talk about, when Jim Rose was talking and when John Michel were speaking, they were trying to show us so many physics behind what you are producing. We appreciate that, but we would like you to always try to cascade what you're saying. Because when you are talking, some of us are tuned backward, some of us are taken aback. We really need to understand what you're talking about. We know that in summary, you are talking about this power surge, and the way she has explained that, all of us became so interested in your own project. So we would like your presence here in Enugu because we need such equipment in Enugu State, most especially as we are transiting from non-renewable to renewable energy. So it's very, very welcome. So I would like everything that you're doing to be cascaded. Let there be training of the trainers so that when you come down here, people will be here to talk to us on a personal note. In other words, we are still going to bring everything together, bring them together based on what you are saying now, and you will see the resultant effect from our side. Now, in the physics aspect of it, it's all about you plugging something. It's all about you attaching a kind of equipment to your homes. I can see from what Jim Rose presented that there are so many aspects. It cuts across every aspect. issue of water, health, and environment. So we know that what you are saying here is very, very important and so paramount. I would like you to just join us in what we are trying to achieve in Enugu State. We are moving from non-renewable to renewable. Everything we are trying to move on smart energy when you come to the school, when you come to the roads, when you come to all the sectors of this very state. If you only go to health department, some of you that are in Abuja, you find that we have already started doing, health has already started their own health national adaptation plan. And all these things are keyed into the SDGs, SDGs 7, 8, 9, and 13. So we want to key in, but we want it to be cascaded in a way that most of us will understand what you're saying, so that as we go back to our ministries, we can tell our principals what we have just learned from this very place, so that we can join you and then move together in alignment with your own framework. Thank you very much.
Can you just reintroduce us? We didn't catch his name. Enugu, can you hear me? Can
Yes.
he reintroduce?
Yes, you can hear me right now. My name is Arum Namdi, the Deputy Director, Climate Change Department, Enugu State Ministry of Environment and Climate Change. Thank you.
Thank you very much, sir. Thank you. Thank you for that comment. Any other comment from Enugu?
Yes.
Go ahead.
My name is Engineer George Mume. I'm the MD of Midas Engineering Limited. From the talk and the presentation, most of the surges come from the generating and the transmission stations, and finally to the distribution transformers. I would like to know from the presentation what technology they have to mitigate the surges from the source, because that will help reduce the nuisance we have from the end users. Thank you.
Thank you, Engineer George. Well, John has been talking about the sign timer, and Jim talked about it very well. You just have about 20% most destructive surges coming from the utility lines, of course, or from lightning, which of course will ride the utility lines. You have about 80% of that generated internally within the factory or within the building due to those the switching transients. So the sign timer will be able to help you when it comes to transients right from the service entrance. Okay? With that, that's your first point of check. You're going to have a rest of peace of mind. And then for any load that is critical, we can go downstream to deploy the right size of sign timer unit or any of the solutions that are required, as John showed us. If it's a harmonic issue, if it is just transient issue, if it's super harmonic, we have all the fleet of solutions that would help us to resolve that. But primarily, you mentioned such, the sign timer is the one that will help you do that. Angie, I know you're in Enugu. Can you show him the box, the sign timer box? I know that's the dummy type of it. Press the button that shows green and show engineer so that he will have a feel of what it looks like in the real life. Yeah, that box that has sign timer. Let him see what it, good. All right, that's a three-phase unit. That should be RMST40, three-phase unit. Only that one can handle 400 amps capacity, panel or load. Okay, now it goes all the way 3,000 amps, and you can go way, way beyond that. We can make 10,000 amps unit in one box for you, and the result is absolutely the same. So what you're holding in your hand is a dummy, but that's how the real one looks like. The real one looks like that. And sometimes it does come with surge counters that I'll be able to give counts of the surges that it clears. Okay, so we will work with you in Enugu. I'm so impressed, so happy, and Amaka has done a great job in Enugu. Thank you so much. Any question for John before we move to the last 1 minute to give the support people a minute to say something about how we support our warranty and all those stuff. Any other comment from the Lagos? Okay, Benson, you're in Abuja. Are you still there?
Yes. Good afternoon, ladies and gentlemen.
Good afternoon.
My name is
I'm in
Williams.
Abuja.
Williams Ajizi.
Team.
My question
Benson,
is...
hold on, Benson. Let's hear Enugu.
Okay.
Just stay close.
Okay.
Go ahead, sir. Enugu, go ahead.
My question is about this equipment.
Yes.
I want to ask, is this equipment, are they cost effective? Because from the look of things, it looks very sophisticated. Is it cost effective in the sense, can homes afford it if we started having it in Enugu State?
Very good question. Cost effective, the answer should be yes. However, the cost is dependent on how much the need is to you. If you have a machine, like I see some people, they invest in $1 million machine, or they buy 5K mega screen TV for their beautiful home theater, and it's about $6,000. And then they ask you to protect that. You say you want to protect it with a $100 surge protection device. Congratulations, we point you to China. If your 5K TV is very important to you, you want to make sure you protect that. And remember, only one strike can take out everything in your house. Your TV, your dishwasher, your laundry machines, everything can go, plus the house can go on fire. So it's very cost effective, but it also depends on what it means to you. What does your investment mean to you? How much do you really want your investment to last for you? That will determine how much you will want to spend on that. You want to go for surgery? Do you want a doctor that will check the brain, repair something, or do you want a doctor that will amputate your hand? The choice will be yours. You would rather want to go for a brain, scan, and they just repair something in the brain. Your hand will start working, as against the doctor that will say, well, the only solution, we cut the hand and we'll put a prostrate arm for you. You see, the two of them are solving problems, but there are different ways of solving the problems. So bottom line is they're cost effective, and we're willing to work with you as customers, as channels, as ambassadors of the products, okay, to make sure that we solve the problems that we have in our society and have peace of mind at the end of the day. We want to create something, that a legacy that our children will still see those companies running, and they at least get experience from there before they start out their own. All right. If that question is answered, any other one from Enugu before we take up? Unless John, you want to add something to that answer? I don't know if you have a different version of cost effectiveness from your customer experience, when a customer is asking if it is cost effective.
Yeah, that's a really tricky one. I think you expressed it really well, Tim. What I would say is it comes down to return on investment, right? So I think we have a world record somewhere. Jeff can probably confirm this, but I know in Europe we did a case for a customer, and the payback for the customer was less than like 1 minute, right? But on the other extreme, when you're talking about households, that's a different problem altogether, right? Industry, it's very easy to quantify payback. A household, someone has to put a value, personal value, I would say, on what are the risks. So kind of two different things really, and you have to weigh on your heart, or your customer might have to weigh on the heart if you're talking about residential applications, that you just need to think a little bit stronger and harder on what does it mean to you personally to be protected, right? So yeah, nothing more to add on that really on that side. But in the factories, yes, definitely the cost of downtime and the profit to the shareholders, and cost of not being able to produce stuff while you've got ingredients coming in, or whatever your system is that it's producing is a real problem. So it's minutes of payback,
Excellent. Well, thank you so much, Enugu, for that question. Any question from the hall here in Lagos? All right, Benson in Abuja, are you there? Just 1 second before we get Hiral to talk about the support in just 3 minutes, and then we shut it down. Are you Benson?
Yeah. Yes, I'm here, Tim.
All right, I called up your experience before. You talked about the 80 kilowatt site that was built, but it can't power up. Can you share just half a second about that particular situation and our confidence in resolving that in Abuja?
Yeah, nice one. Nice sessions. Very great and intelligent systems. Basically, like somebody said, I mean, there's a lot of transition. So you see a lot of transition into renewable systems. But a lot of times when you need the power from the grid to also help in like an hybrid system, helping sustaining your battery powers and stuffs like that. You see, those powers are not clean, like the situation we have. Getting clear three-phase system from grid in Nigeria here, I think is absolutely impossible most times. I called on a team, and he's preferred some very great solutions from the bouquet of what we've had today. I think there's so much confidence when we work on power systems now, knowing that solutions like this exist here. So I also want to plea that the recordings for these sessions are shared, so we can also share with people who were supposed to be here and didn't make it because of business commitments and other stuff. So that's my plea. Wonderful thing. We're here to work with you in Abuja. I think I also I also find Green Capital. Are you here? It's one of our big players in the renewable energy sector in Abuja. Green Capital. Chinedu Ibezimako, are you still online?
I think I saw that name online.
Are you still here? I think he went out. So he's one of our big players as well in renewable. In fact, he has his own patent products that he delivers. I was able to drag him in here. He's been here for a while. So we in Abuja are ready to work. I mean,
okay, yes, Engineer Benson, I'm here. Sorry, I couldn't unmute. I think it was from the host.
Yeah.
Okay, I think Mr. Ibezim is
great. Okay, great.
Yeah, Engineer Ibezim is there.
Yeah. So I guess he's here as well. I think these are great products that we can work with and profile good quality solutions. So you can drop a word, Chinedu. Thank you.
Hello.
Yeah, Chinedu, you can also talk.
Yeah, I think my network for some reason is not stable.
We can hear you very well.
We can hear you.
Okay. Are you asking me something?
Yeah. What is
I said your experience.
And your confidence that your solution problems are going to be solved right now, that you now know we got a bouquet of solutions for you in power quality. How confident are you to face the challenges?
Okay, so experience you're asking, sorry, let me get that from Mr. Benson. Experience you're asking, is it regarding challenges?
The solutions you saw today here.
Network. Hello, come again.
I said the solutions that were projected here today.
Okay, experience in terms of our solar solutions we are providing?
No, experience in terms of solving some of the problems that we encounter, three-phase challenges. I mean, when we want to use the grid hybrid system for solar solutions, having products like this will help us in solving problems like harmonics, problems with grid reversal and stuff like that.
Yes, absolutely. I mean, we are coming from the area of a very classical technology. We used to deploy, for example, if we have to deploy a 50 kVA system before now, we used to deploy the systems from Megatech, this Indian system, three-phase, high voltage, IDC voltage, and all of that. So, like in Nigeria, one of the major problems we have is that for some of the sites, when you deploy, either you have one of the phases not working for some reason, one of the phases is yanked off, and once the phase is not complete, the system will not be able to power. So we had that problem, but right now with this new technology we are having from you're having DA, you're having TBB and some of those folks, they are bringing in systems that you can run on single phase. And but I think the major issue we're having right now, if I can say for a fact, is protection devices. Which is where I got more interested, protection devices, because protection devices as protection systems, most of the buildings, you won't even believe, some of the buildings that you see a lot, what they do there, their protection system is nothing to write home about. The builders here, they don't really focus on, they don't infuse professionalism when it comes to the electrical part of what they are doing. And imagine you come and you want to deploy a system and the thunder arrestor is not potent enough. You do earth resistance test, is very poor. So we have had that challenges. We're using SPDs. Sometimes the SPDs are not good enough. So from what we have seen,
now you've seen the SPD that is the number one. So
yes. It's very. I have my head of technical here because I have not been very focused, but I know that I told him to pay more attention because from what I have seen, I think that what I have seen solves a whole lot of problems for us, and not just for us, because we have a pool of folks that does what we do. We are one of the old ants, so we have a pool of folks that we're going to also introduce this to. We have a very good channel to commercialize it also, so I think it's good. We would like to see where we can go. Well, we would be very much interested in having this device and then see where we can go from there.
All right. Thank you very much. Thank you, Engineer Ibezimako and Engineer Benson. Thank you so much. Thank you so much, John. Now, just for last minute, let me see Hiral from India, TSI Power India for support. I don't know whether you're still there. That's name here, admin. Okay, this admin should be Hiral. Can you unmute admin, please? Unmute admin. Hiral, we just talk 1 minute, the idea to support for the TSI Power, to give us the support that we need around the clock. We got Francis in Singapore. I guess he must have gone to bed maybe. So there must be support, within the time zones at any time. Somebody is hopping on board to support you, even though these solutions don't even need your maintenance, to be honest with you. That's why Saintama is 25 years warranty, yes, and the other ones run many years. John just showed us the one that been running for 7 years in the UK. In Denmark, 3 years, no call for maintenance. But Hiral is right here. Hi, Hiral.
Hi team, how are you? Hi everyone.
Good. So just to give them the confidence that look, we have TSI India very close to support. Okay, to offer the much support that we can, and of course from the US we might be a little bit far away, but we cascade things down through the India, and they will have all the support that they require to keep things moving at any point in time.
True. That's good. Hi
Good.
everyone, can you hear me?
Yeah, we can hear you.
Audible? Great. So hi, I'm Hiru Gandhi everyone, representing TSI India. I'm looking after export sales, and basically we serve African and all Asian countries from India.
Cool.
Yes.
Excellent. So most of you will be, that means in the course of time as we progress, they're going to be interfacing, especially the team will be interfacing with you for all the support we need as far as export sales is concerned. All right. That's the confidence we want to be able to show them in Tanzania, across the world, across Africa, those who are connected, Kenya, everywhere, that we have the support system. Because American Towers in Tanzania gave me a challenge, and they were like, oh, we are so big on support. I'm like, we got the support you need 24 hours a day.
Right.
From everywhere. We got it. If we need to get, I know it's tough to get John to be in the plane because John is fully booked for the next two years possibly. Even Mr. President, Jeff Edwards, can jump in the plane and solve the problem, because we enjoy what we do as engineers. We enjoy solving problems. And we want to make sure you have all the support you need. So have confidence in us, have confidence in our solutions, that look, you're not just dealing with one person, you're dealing with a network of people who love to solve problems and they're happy about it, right? Great. So thank you very much. I want to call up Enugu quickly for a vote of thanks from Enugu. Let's get Engineer Amaka. Let's get Enugu for a quick vote of thanks. I want to thank her. She worked so hard. This was a short notice, very short notice, and she pulled it off in Enugu. You know, is she there, Enugu?
Good
I
afternoon.
think that's
Good afternoon.
camera.
everyone.
Seeing who is talking, please. Enugu Media, please. Okay, good. We can see her. Can you pin her? All right. Go ahead and thank your people, Angie. Good.
Good afternoon, everyone.
Good afternoon.
So, first of all, I want to thank Mr. Timothy for making me part of his team today. And I want to thank everybody here that have come here today to be part of this program. So I appreciate you all being here today despite all your busy schedules. Thank you all for joining this program. I appreciate you all. Thank you.
Excellent. Well done for the job. Well done. You've made everybody proud. Thank you for assembling people from the government. I was really impressed. People from the government, people, managing directors on a short notice. And God just granted you so much favor. And we'll work together. We'll see the plans we can have together with a team on ground to do a visit in Enugu. And like the director said, we're going to work with him and his team to, as a transition, you know, like he mentioned, we'll provide you the support you need as much as it falls into what we can deliver to you. Thank you so much. Now from Lagos, let's take one participant experience or two, and then we will shut down. And you don't want to know the history of this wonderful man that is with me here. And thank you, Pastor, for being so patient. He's a big example to me. In this room, you have procurement directors for your information. And sometimes it's not only the technical people that you want to bring. Okay? That's why you don't look at people because they're not wearing tie. You'll be joking. I met a young man in Tanzania. He was just wearing T-shirts. He was the one signing the stuff. You just neglect him, you are finished. So, sir, experience.
Thank you. Good afternoon, everyone. And thank you for coming and participating in this particular program. Thank you for inviting me, Engineer Tim. My experience has been exciting and impressive. I mean, we have such products available to use in the country. It will really help the power system and the power industry. So it's a very good product. One thing I will ask the company to do is also to bring up industrial or vertical use cases and simplify it, maybe in an animated way, so that people can easily understand. Because from what I can see, it's almost like a plug and play. Once you discover the problem, you can do it yourself if possible. So this can also help in having a mileage across the markets commercially. Talking about commercial too as well, I really don't know how pocket-friendly the product is, even though I've heard that it's a bit expensive. But looking at the country and the economy, we need to make it very pocket-friendly and easy to get. We don't want even the Chinese guys to come in and start cloning it as well, making it, you know. But I see that it's a very efficient product and solves almost every power-related challenge that might be available, especially for us in Nigeria here. Our power is always very fluctuating, intermittent, both of you. So thank you for this expose. But we'd like to take it further so that people can embrace it more. And I really want to thank your company for pulling this and enlightening everyone around. Thank you so much. Thank you.
At least Lagos, put your hands together for him. I know that I want to take one customer experience from this Alhaji. Alhaji, your experience.
Good day, everyone. This is a long-awaiting solution to me. We've been coming from the telecom industry to the power transmission industry. We are ready to face, I can assure you we're going to partner with you. We've introduced this to some of the discos. We are discussing with them. The teleco industry, I saw Pan-African Tower, they are big players. I'm very happy they are here. We are working with them already, and we are going to continue to work with them. They are one of the big players in Colo in Nigeria. Give it to them. They are the upcoming giants. They are there already, overtaking a lot of the existing ones. And I'm happy I can see them here. MTN is a home call for you. Why we also handle the Eco Electric and in installing their transformers. What we need to do, that I promise you, you and I will have to work together, is to get this product registered with NEMSA. We have to work towards that. Once it's registered with NEMSA, so it becomes an official product. Whenever they are recommending their surge, whenever they have, power problem is common in Nigeria, take it. But what I can tell you is we are not resting. And we've been together with Tim for over a decade. I know what he can do. So when he calls me, I didn't question it. I just tell him, look, I'm on board. I know him very well, and one of our bosses is also here, Dr. Agbana. So thank you very much, Tim, for getting us on board on this. And let's go, what do we say? Let's get on board. Thank you, everybody.
Thank you so much. Thank you very much. Just for your information, before we just round up, in this room, all this thing we're doing was inspired by just a little spark. The man that made me know that, boy, you can actually make money. You can give service. It's possible to do PP, you know, that kind of a thing. It's possible to think, wow. He called me, he didn't give out my bank account. I want this done in 24 hours. How much is it? This is it. Boom. Young boy holding cash. I said, what is this? And that gave a spark. Like, JOB is a good thing, but you know what? It's good to get to the point where I could serve like this. That was how the inspiration started coming. And I want to thank Mr. Emeka, my boss. Thank you so much, sir. Just say hello to the people before we close, if you can.
Good evening, everybody. It's been a pleasure to be here with you, and we've learned so much. I'm really proud of this new innovation and technology Tim is bringing to us. I've known Tim for some time right now, for some years, and he's been, one thing I know about him, he has integrity and he works very hard. So congratulations and thank you very much.
All right. Let me just say thank you to everybody that has just attended. Thank you for the media team. Thank you, Pan-African, we'll see briefly. And of course, some people in NTN are watching. Some of them are watching on YouTube. Tanzania, I want to thank you. Kenya, Cosmos, thank you so much for all the effort. And Jim, thank you so much for flying in from South Africa just for this. You know what it means? I was like, man, this half of Jim, man, is making the man that is times two of him to fly from South Africa just for a day into Nigeria. And I'm glad you've enjoyed Nigerian food. He likes our food, and it's a good experience. We're going to do more, and we're going to be in more places. And I want to thank Nampeg from TSI Power in the USA. We launched Barbados last October, and next will be Trinidad in the Caribbean. And like that, we're going to take the gospel of this beautiful power quality to different parts of the world and create opportunities for people and solve problems as we go. Thank you, Enugu team, amazing. And Andrew in Tanzania, thank you so much. Oh my goodness, let me not forget to thank Alphonse. Alphonse, well done. Well done for the push, and I want to thank the Ministry of Health, TCAA. Thank you so much, NMB Tanzania. I appreciate you guys. I see all of you. We'll hope to see you very soon, face to face. I know it's been a while. I will see you soon. And John, I want to appreciate you personally, and I do hope we have more opportunity to do this thing on a larger scale. It's a conference. We're going to start planning for next year on a big scale right after this minute, so that we can take it out. So it becomes a big event in Nigeria that will attract the cream de la cream of the industry. Nigerian Society of Engineers are aware of this. They were supposed to be here. I'm not sure they came in, but I'm sure they are watching. We're going to reach out also to Association of Electrical Consultants of Nigeria. Asset Tanzania, I think some of them are also connected. Association of Consultant Electrical Engineers of Tanzania, they're also connected. So like that, we reach out to people and make them aware that solution is available. Oh, okay. Okay, before we close, can we just put Osita on the line? I think he's a research. He's Dr. Osita, I think so. Dr. Osita, all right. Yeah, he's a power quality PhD. PhD. That's good. Can you find Dr. Osita? Unmute him, please, quickly, before we just round up 1 second. Our time is fast spent. Dr. Osita?
Okay. Yeah. Thank you, everyone, for this wonderful opportunity for us to hear more about power quality and then the solution you have for us. Honestly, I've been researching, working, gathering power quality data for since 2010 or 2009 or thereabouts. That's about 15 years ago. And I've seen so many issues, so many power quality issues in the industry. And it has been in my heart, to see this kind of scenario where solutions can be profiled for, power quality issues, because these are things we don't know much about it in Nigeria. Most places you visited to capture power quality issues. Of course, I've traveled throughout the whole country from one power installation to the other, trying to capture data. And they don't know all these things. And this thing are causing serious problems. So it has been in my heart to, see this kind of company that can come up with, solutions to power quality problems. It's actually it's a very big problem. In fact, one of the things I advise you to do is to create more awareness, because people don't know it. It's, when somebody is sick and doesn't know that he's sick, it's very difficult to cure that person. But when that person realizes that he's sick, then the person will take steps to get the problem solved. So I'm highly excited to although I came in late because I'm engaged in another thing, but when I came in, I saw some of the solutions you profile and all that, and I'm excited. So I don't know what you have anywhere in Lagos here. I would like to know more about you, and you can see how I can link you up to some customers that have this issue. Many of them, done power quality capture, data capturing, analysis, and all that. They need this kind of solution. So I think, it's a very good thing. It's a wonderful thing. So thank you so much for this opportunity.
And then finally, let me thank Mike. Mike B, thank you so much, Mike. Now, Mike is also on ground with a signed message, for some years now, helping out. So we have the workforce to start right away on ground. Alaji is here, Transcorp, okay, on ground. Right there in Enugu, Jabion is there, Amaka is there for you to reach out to. But this information that we have today, if your email is on the table, we'll be able to share this link with you. So at your free time, you can watch, and we can attach the presentations that you saw today. So at your free time, you can go back and consult with those information to, get it really, really deep down. Thank you, and I appreciate you, and I want to thank God for the grace and the great privilege to be here.
Amen.
To fly down just for this. It's a privilege, to be honest with you. Jim, I want to thank you again. I want to thank Jeff for allowing you to come down, and thank my wife and my little baby boy for letting me go, just like that, and leave them behind for a few days. Thank you so much for being here with us all through today. God bless you as you get back.
Tim, one more thing.
Keep you until the next year's Power Quality Conference is going to be bigger and better, and trust me, it's definitely going to be bigger and better. All right. Thank you for coming.
And that happened right near the 18th green again. Our lock cameras caught that bolt. And let me just tell you, it wasn't too far from our booth. That is a live look at the tree. And it was shook.